This is GCSE Further Maths Pure. We're looking at differentiation, and now we're going to look then at the equation of a tangent to the curve. So the equation of a straight line is of the form y equals mx plus c. You should remember that from a couple of years back. The gradient of the curve at the point P is equal to the gradient of the tangent at that point. So remember in the previous videos or the previous bit of this course, we were realizing we were finding a gradient at a particular point. So the gradient of the curve there is the same as the gradient of the line. That's what we're saying. To find the gradient of the tangent, we firstly find the gradient of the curve at the point P by differentiating and substituting for x. Then we use the coordinates of P and the gradient of the equation to calculate C. So what do we need to do? Find the gradient from differentiating the curve. That'll give you the gradient of this line. To find the equation of a line, you maybe remember from GCSE maths that you need a point on the line. We have that at P. And the gradient of the line, we substitute those into y equals mx plus c. And that will help us with it. Okay? So find the equations of the tangents to the curve at 1, 1. That should just be the equation then of the tangent. So find the equation of the tangent of the curve at the point 1, 1. So first of all, we're going to differentiate. We're going to find dy by dx. dy by dx is of course then going to be 4x minus 3. And we want then the gradient at that particular point. This is the gradient function that will tell us the gradient at any particular point we want to know it. But we want to know it then at 1 minus 1 dy by dx is equal to 4 upon 1, take away 3, so it's equal to 1. Therefore, m equals 1. So the m and the y equals mx plus c. We have that then worked out. Okay? So at the point 1 minus 1, we're going to have y equals mx plus c. So it's going to be y equals 1x, which we would write down as x, and we also know the point 1 minus 1 works. Our numbers are very straightforward here, but that's okay. Remember, minus 1 is the y coordinate. So minus 1 equals 1 plus c. That means c is minus 2. Down to a bit more space. Therefore, equation of tangent at 1 minus 1 is y equals 1x, if you remember, so it'll be x, and then, sorry, that should be a minus 2. I think I maybe said minus 2. X minus 2. Let's take a look at example 2. Find the equation of the tangent to the curve y equals 2x squared minus 3x plus 4 at the point where x equals 3. So again, we're going to find dy by dx to try and find our gradient then at that point. Minus 3. So at x equals 3. dy by dx is going to be 4 upon 3, take away 3. dy by dx then is going to be 12, take away 3, which is of course 9. Therefore that tells us then that m equals 9. Now this question is very slightly different from the previous one. Do you remember in the previous one it gave us the actual coordinate, the x coordinate and the y coordinate, which we subbed into y was mx plus c. We don't have the y coordinate here, so we need to find the y value. So we need to find y value at x equals 3. So of course we can find that by substituting 3 into here. So if we go y equals 2 upon 3 squared minus 3 upon 3 plus 4. That's going to be y equals 3 squared is 9 times 2 is 18. Take away 9 plus 4, and then y equals 13. So we're going to then substitute into y equals mx plus c. That's y equals 9x plus c. Then at the point 3, 13, we're going to have 13 equals 9 upon 3 plus c. 13 equals 27 plus c. And so c then is minus 14. Therefore, the equation of tangent is y equals 9x minus 14.